now we're going to keep going with the academic chemistry, Unit 1, Topic 6, which is measurement. We're going through the math, and today now we're going to do the addition and subtraction rules. So to start, you're going to want a calculator to work through today's problem. So if you don't have one, please go grab them to make sure that you're going through everything properly. So as there is a lot of math in chemistry, so the main rule that you want to keep in mind doing any math is when calculating your final measurement, you can't be more precise than your least precise measurement. The heck does that mean? Okay, that's the official way chemists say it. Let's do an unofficial. Alright, so this isn't chemistry, this is people. And if I quickly look at this crowd, I'm going to estimate that there are 100 people. Which means that my 1 here is the only sig fig in this measurement. What that tells me is I've estimated the 1. I don't know any of the other digits. This could actually be 100 people straight up. I don't know. It could be 105. It could be 140. It could be 148. It could be 97. All I know is the 1 is approximated because it's my last sig fig. If I'm adding 3 more people to it, I'm saying this is approximately 3. Now, I realize it's a little weird to look at because you look at this and you say, there's definitely 3 people. But remember, we're talking about chemistry where we have graduations, we're taking actual measurements. So if I put these together, I cannot say that I have 103 people. Because if I don't know these digits here, I can't suddenly say, oh yeah, that's definitely a 03. I say this is still about 100 people. Because this is more precise than this. I have to go with the precision of my least precise measurement. So let's do this in real chemistry terms now. The first step in addition or subtraction in chemistry is the easiest. You just do math like normal. If I have 8.15 meters plus 3.2, I still have 11.35. I think I remember those numbers, right? So just type it in a calculator, whatever you get. Then you find the last sig fig in each of the measurements that you had at the beginning of the problem. Whichever last sig fig is in the largest position, and when I say position, I mean these, 100,000s, 10,000s versus thousandths, 10,000ths, right? You're going to round your answer to that position. Now remember, these are going to be bigger than these. So we're going to use this number line here to help evaluate where the estimation happened in each of our measurements. Let's do a practice problem. I've got 6.05 meters, I'm adding 3.103 meters, and I'm adding 4.5583 meters. Step 1, do math like normal. So I want you to type all this into your calculator, write it down, and then check to see, did you get the right answer as me? Okay. Type in your calculator. You can freeze the video if you need more time. Did you get 13.7113? If you did, awesome. If you didn't, we need to talk about that. But, okay, we're going to move on. So the next thing we need to do is evaluate what is the last sig fig in each measurement. So in 6.05, these are all significant, so my 5 is my last sig fig, which means this is where I did my estimation. And then I'm going to find it here. So that's 2 spots after the decimal, 1, 2. So that got estimated to my 100th position. My 3.103, the last 3 is my estimated position. That's in the 1000th position. My 4.5583, we have another 3, and that's in my 10,000th position. So which of those is the largest? So what has the most in our measurement? That's going to be the 100th. So that means our answer can't go past the 100th position because I don't know things past the 100th position. So here's my 100th. So our 1 here is what the last digit can be in my answer. So I'm rounding at this point. I look after, 1 doesn't bump it up, so it says 13.71 meters. Let's do another one. I've got 80.807 milliliters, and I'm taking away 5 milliliters. So first, do it in your calculator. 75.807 milliliters. Then I evaluate the last sig fig in each one. So on 80.807, my 7 is my last sig fig. That is 1, 2, 3 spots after the decimal, so it's in the 1000th position. In 5 milliliters, my only sig fig is 5, and that's in the 1s position. Which of those is larger? The 1s is larger. So I did my biggest guess same at the ones position, which means if I guessed here, I don't know what these are for sure, so I can't go past this in my answer. So in my answer, here's the ones position. That's where I'm doing my rounding. So if you look after the 5, 8 bumps it up. This becomes 76 milliliters. It's a little more complicated with scientific notation, but not bad. The first thing is to make sure you have the same 10 to whatever power. If it's not the same, you need to convert all of them to match whatever has the largest x on it. And this is because the 10 to whatever power, those are your placeholders. So remember when you first were learning how to add and subtract, you line up your decimal place. This is just lining up your decimal place in scientific notation. Then you do the addition or subtraction, whatever your problem needs, with your coefficients. And then you keep the 10 to the x power the same. So here's a practice problem. If we look at our 10 to the x, I've got 10 to the 5th, 10 to the 2nd. Those are not the same. So which one is bigger, 5 or 2? 5 is the same, so this is the goal. We need to make this measurement now have 10 to the 5th. So we need to evaluate our 3.40. Since I'm multiplying it by 10 2 times, I know my decimal in real life is to the right, and it's to the right 2 spots. So here, let's imagine, is our real decimal. We want our coefficient decimal to be 5 spots away from my real decimal. I can't move my real decimal. So if I'm 2 spots away, and I want to be 5 spots away, then I need to bring it back even more. I need to bring it back 3 more spots. This can't change. So right now I'm 2 away. I want to be 5 away. I need to go back 3 more. So 1, 2, 3. Come on. There's the animation. All right. So let's rewrite to make things a little clearer. And my 5.03 times 10 to the 5th stays the same. And then I'm adding 0.00340. This 10 to the 2nd is now 10 to the 5th, and everything is grams. I add up just our coefficients, so 5.03 plus 0.00340. That gives us this number. I bring my 10 to the 5th down, and now I do my rounding. So I can look at these for our decimal places. Our last sig fig here is a 3. Our last sig fig here is a 0. If we look, this is bigger, so I have to round to this position. 3 does not change it, so it stays 5.03 in the beginning, and 10 to the 5th sticks around, and grams. Let's do one more. So I've got 8.2 times 10 to the negative 7 centimeters plus 4.9 times 10 to the negative 6 centimeters. So first we evaluate our 10s. Which of these is bigger, negative 7 or negative 6? Remember, it's negative, so it makes it a little weird. The negative 6 is actually larger. So I need to change this decimal place so that this becomes 10 to the negative 6. Since this is negative, my decimal place is actually to the left. And it's to the left 7 positions. I can't change where the real decimal is. But I want the distance between the real and the coefficient to only be 6. So I need to bring this decimal back 1 spot so that I have 6 positions between the real and the coefficient. So I'm going to bring this decimal back 1. When I rewrite that, it's going to be 0.82. This 10 to the negative 7 becomes 10 to the negative 6. And then the second piece doesn't change at all. We add up just the coefficients, 0.82 plus 4.9. So this gives us 5.72. Our 10 to the negative 6 comes down as is. Now we can evaluate our sig figs. Our last sig fig here is 2. Our last sig fig here is 9. So the 9 is in the largest position. It's in the 10th versus the 2 is in the 100th. So we estimate here. 2 doesn't bump it up. It becomes 5.7 times 10 to the negative 6. All right, here are some practice problems to do on your own. So I want you to go ahead and freeze the computer. Try these out. Be mindful of number 4. It's got 2 different units, so you have to pick the same unit first, convert one of them, and then add them up or subtract them. I'm going to put up the answers for you, but I want you to freeze your video now, so when you come back, you'll see all the answers. You can check them, try and find any mistakes. If you have any questions, come find me during class, shoot me a message on Remind or an email, and I'll try and get back to you. All right, hope you did good. If you have any questions, come see me. Otherwise, I will see you in the next set of notes. Good luck on this section.